Hello everyone, my name is Pearl Mukuru and this is my Teach 1 for Dependence Networks in HAP H23. So question 1 is, for the following data, estimate chi-square for complete independence, 3 joint independence models and 3 homogeneous models. And the second question is, which model best fits the data and why? The first thing we need to do is to prepare our data for analysis in R. The data was binarized in the following format. In the column MD, Smith was changed to 1 and George was changed to 0. In the column RN, Jim was changed to 1 and Jill was changed to 0. And in the column complaint, yes was changed to 1 and no was changed to 0. But the observed counts were left alone. This is our table after we have binarized our data. The second thing we need to do is to save that file as a CSV file and read that data into R. The first thing we need to do is to estimate chi-square for complete independence. The simplest model that we propose is that RM, MD, and completes are independent of one another. And we can graphically denote this model like this. In R, we use Poisson regression to determine complete independence of our variables. Poisson regression is similar to regular multiple linear regression, except that the dependent variable is an observed count. This is the code we used in R, and this is the result of the analysis. The results show that the sum of our predictors with no interactions are statistically significant. The second thing we need to do is to estimate 3 joint independence models. What this model implies is that 2 variables are jointly independent of the third. This means that A and B are jointly independent of C. Using this in our example, that means MD and RN are jointly independent of complaints. And we can denote this model graphically like this. The code used to determine joint independence is similar to the complete independence model. However, the association between 2 variables is added to the code. This is Rn asterisk MD in this particular example. The results show that Rn and MD are associated because they are statistically significant. The second model is testing the joint independence of MD and complaint. The results show that MD and complaints are associated because it is statistically significant. The final model is testing the joint independence of Rn and complaints. The results show that Rn and complaints are not associated because it is not statistically significant. The third thing we need to do is to estimate 3 homogeneous models. Homogeneous association implies that the conditional relationship between any pair of variables, given the third one, is the same at each level of the third variable. And this is how we can graphically represent this. In R, we first determine the homogeneous association between all our variables, and this is the formula we used. The first homogeneous model drops the pairwise link between Rn and MD, and these are our results. The second model drops MD and complaint. The third model drops the pairwise link of Rn and complaints. For our second question, we need to determine what model best fits the data and why. We can determine what model best fits our data by looking at the residual deviance and degrees of freedom. The residual deviance is a measure of goodness of fit of a generalized linear model. A larger residual deviance indicates a worse fit. We also want to determine what model gives us a better fit for 1 degree more loss of freedom? So what we do first is to record the residual deviance and degrees of freedom for every model that we did in R. This includes the complete, the 3 joint independence, and the 3 homogeneous models. The model with the lowest residual deviance is the homogeneous model, with a residual deviance of 0.37124 and 1 degree of freedom. If we remove the association between Rn and complaints from the homogeneous model, there is a 2 degree increase of freedom with an increase of 5 residual deviances. Therefore, the smallest loss in residual deviance is associated with removing the association between Rn and complaints. This model is the model that best fits our data. And this is how you answer question 1 in dependence networks. Thank you so much for listening, and good luck on the other questions.